Here is target 3.3. I can add and subtract rational expressions. I would say this is one of the more commonly difficult targets for students. It tended to be the reason or the misstep for other targets is that they were trying to use this goal for other ones. So this is the only one where there's no canceling, which is kind of bizarre because I feel like that's been the name of the game for all the rest of them, no canceling. So this is the one we're going to modify. So we need common denominators, which is just getting the bottoms the same. And then once that's the case, your goal then is to only work with the tops. So once we have, like in example number 1, we'll have common denominators. Your goal is to get it to look like number 1. Let me get my laser pointer. Where I have identical denominators, so my bottoms are the same. That means we can then focus on the operation and we can just add the tops. So we'll kind of like reiterate the steps in 2 and 3, comparing it to number 1. So if you can get number 1 correct on a retake, that automatically gets you to a 2. So again, we wanted to identify that these are the same. So then we are just going to add the numerators. So we're going to add the numerators. So I guess I shouldn't use an exclamation. I should be like, that's the check. We need them to be the same, and if not, you'll see in number 2 how to modify that. Once they are the same, then we're ready to do the next step, which is add the tops. Okay, so we're going to take 8x, and we're going to add it with 3x minus 1, and that goes all over our common denominator, which if you think about talking about, I usually go back to my reference of pizzas. If we're comparing the number of slices we eat in pizzas, like I ate 1 slice of pizza, and then someone else is like, whoa, I ate 3 pieces. Well, the minute I tell you that there was only, I didn't cut the pizza and it was just the entire pizza, well, clearly that person ate more pizza because they ate the entire pizza. The minute you know the size or the amount of slices in a pizza, then we can start to compare the true number that we ate. I could be like, oh, I ate 8x and you ate 3x minus 1. We can kind of be like, well, we know that's the same percentage of pizza because each slice is worth the same amount. So again, why do we need the bottoms to be the same? It's just so that we can have the same conversation. We need them to be the same. The minute that's the happenings, then sure, all we're doing is adding the tops. So number 1 ends up being quite a little bit simpler of a problem because all we're doing is adding 8x with 3x, which is 11x minus 1. And that's it. We don't do anything more. We were given the same denominators, so we just work with the tops. So now when we look at number 2, I can see that I have 2x plus 5 as the denominator of my left fraction, but in my right fraction, I have 2x plus 5 and something else. So outside of the parentheses means that it's being multiplied. So 7 has another factor living in the bottom, and so we need to adjust. This is us getting common denominators. Need the same, so we're going to modify. And how do we modify? We use multiplication. Need the same, so multiply. This is like, I guess, what's missing, to use the language we used before. It's the what's missing, so let me write that too. Oops, I thought that would be a different color. Sorry, I got one of these sound dullers, and it's not quite as reactive. What's missing is our strategy. Okay, so now we can modify. Let me use pink, this is green, to continue my modification. So we have 7 times 3x, which is 21x. And I don't want to disguise my denominator, so I'm going to leave them in factored form. And then, of course, as per my usual videos, if I don't change something, I'm leaving it in black. So all we did was modify our left fraction so that they have the same. So now we're ready. We're ready to do the next thing, which is add the tops, which again, I saw an add over here. So I'm going to just add the tops. to get 21x plus 4, because those are not like terms. And that is, don't forget your 2 in there. That is the final answer for number 2. A little bit more work because we had to get common denominators. But again, we weren't able to talk about the same ratio of pizza being eaten because they didn't have identical bottoms. And because they didn't have identical bottoms, we had to do a little bit thinking to go, who truly ate more pizza? Now, if we look at our last example, this is where, if you looked in your notes, we would call this strategy the switcheroo, which is, definitely technical language here. The switcheroo here, it just means that I'm going to take my denominators and switch places because I have to modify both of them. So my orange is going to come multiply with the top and the bottom on the right, and my green one is going to go multiply with the top and the bottom in parentheses on the left. So the switcheroo is because we literally switch places. Each fraction multiplies, I should say each denominator, each bottom multiplies with the other. And switcheroo is just fun for me to say, multiplies with the other. Okay, so now I'm going to kind of cheat a little bit to remind you that the whole point is to have common denominators, and I'm going to fill it out with black, but I'm going to use the colors. I have my green bottom, x plus 4, and my orange bottom. And now I can kind of rewrite them so that it's easier for my brain to see who I'm multiplying with. So my left-hand side is a little bit distracting for me. I'm going to switch to my laser pointer. I see that x plus 4 is multiplying with negative x, and I think it would be easy to make the mistake of x plus 4 minus x. That is not what's happening. We need to do distribution lines. So whenever we're modifying both, which by the way is to get a 4 on this target, I would probably encourage this second step of let me rewrite with our kind of like our math grammar here, who's multiplying when it's singular is on the front, just like our 3, who's naturally set up that way. Let me switch back to my name. On my right-hand side, it's just naturally set up in the right order that makes our brain a little bit happier. So now we're going to go ahead and work with the top only. So now my red is tops only. So I can only distribute. That is the skill that I see when I look at this. I have some work to do. We will not cancel. Reminder, no canceling in this target. Basically, if you think of it from a teacher's perspective, these problems were already canceled. I took problems from like number 3.2 and decided to add them together. And so when I took away the fact that you already canceled, now you got to reinstitute the canceling. Bring it back. Okay, so again, let's get back on track. Negative x times x is negative x squared. Again, I'm just kind of right here. I'm making a darker rainbow, if you will. And then I'm going to now do negative x times 4, which is negative 4x. And then plus 3x, because positive 3 is going to distribute to both of our orange binomial. So positive 3x plus 3. And that is all over. I'm going to switch to black, our denominator that I'm not going to change. Oh my goodness, you've probably been yelling at me for a while. I have 2 of the same binomials. My orange did not get copied correctly. It should be x plus 4 for green and x plus 1 for orange. My apologies. And so then I'm going to finish writing the bottom. Now my question to myself is, what combines? So what is like? So I think additionally students are trying to do more than is needed. I just want to know who's going to combine in my numerator. I have a polynomial, a 4-term polynomial, but really it's a trinomial because I see that these are like terms. So I can go ahead and combine those, and my final answer is going to be negative x squared minus x, because negative 4x and 3x combined to be negative x, plus 3, all over that same, oh my goodness, Brittany. You can tell I'm a little bit under the weather, but here I am trying to get this done. There we go. That is our final answer. And if you can do all 3 of these, that is 4, a possibility of a 4. If you are only able to do number 1 and number 2, or number 1 and number 3, then that's a 3, which both would be beautiful grades.